Hi everyone, welcome to the Adventure Science Center. We are in our Eureka Theater for today's live science show. My name is Mr. Jason, and because things are getting a little bit hot outside, I thought we'd cool things down with one of my favorite chemicals, which is liquid nitrogen. Now, one of the neat things about liquid nitrogen is that it is so cold at negative 321 degrees below zero that even if it gets into the air, it will go immediately from a liquid right into a gas. So we're going to start today's experiments by seeing just that. Now, I am going to use some safety equipment here today. First, I do have a pair of gloves that I'm going to go ahead and put on. And second, you will see me put on a pair of goggles. Liquid nitrogen, because it is so cold, can be dangerous. In fact, it has the ability to actually burn my skin if it touches it. Things that are very cold can burn just like things that are very hot. So I will be using the safety equipment for the rest of today's lab. I'm going to go ahead and bring the liquid nitrogen right out here, right onto our carpeted floor. I'm going to go ahead and take the lid off and watch in amazement as it goes straight from a liquid to a gas. Now, one of the neat things about that gas that you probably just observed and are still observing is that the gas doesn't just stay in one spot. Gases are gases because they expand to fill their container that they're in, specifically this room that we're actually in right now. What this means is that we can go ahead and do some pretty neat things with the liquid nitrogen and use it to expand other containers. So for my next experiment, what I'm going to go ahead and do is put my liquid nitrogen right here. And here I have an Erlenmeyer flask with a balloon attached to it. All I'm going to go ahead and do is pour a little bit of liquid nitrogen into this flask. We're going to take a rubber stopper and put the rubber stopper right on over the top. Now I want you to watch the balloon, and since we were all young scientists at home, I'd like you to all make a hypothesis. What do you think is going to happen to the balloon when I put the liquid nitrogen into the container and put the stopper on? Take a second to go ahead and come up with your hypothesis right now. All right, do you have your educated guess? Let's go ahead and do this, and let's see if you're right. Are we ready? 3, 2, 1. Let's go ahead and pour it in. And now let's go put that rubber stopper on. And what can we observe happening to our balloon? You said it's getting bigger. You're right. The big question is, well, why? Well, the liquid nitrogen, again, is going ahead and evaporating because it's so cold at negative 321 degrees that its boiling point is well below the room temperature that we're sitting in. This causes it, again, as we saw in the previous experiment, to go from a liquid to a gas. The gas then is trapped inside the Erlenmeyer flask with only one way to go, inside the balloon. And this, of course, goes ahead and blows up the balloon. But what happens if we go ahead and take the rubber stopper off and allow that liquid nitrogen, that's now a gas, to escape? What do you think it's going to do next? Now that you have your guess, let's go see. 3, 2, 1. And now with a new avenue to go ahead and escape, we've made a fun little volcano here, but if you notice, our balloon now is shrinking again because the liquid nitrogen is no longer just going into the balloon, and it is allowed to escape out into the room. Of course, the moment we replace our rubber stopper, it's going to go ahead and blow the balloon right up. Now, my next question for you is, does liquid nitrogen always cause a balloon to expand? Let's find out with our next experiment. So right here, I have a nice large bowl that has absolutely nothing in it. I'm going to go ahead and pour some liquid nitrogen right here into this bowl, and then I'm going to place this already filled balloon into the bowl with it. I want you guys, as I'm pouring the liquid nitrogen, to go ahead and make a hypothesis. What do you think is going to happen to this balloon when we place it directly into the liquid nitrogen? So this time we're not going to fill the balloon with nitrogen, we're going to drop it straight on in. So go ahead and come up with your hypothesis as I pour this out. Should be good enough. And here we go. Ready? In 3, 2, 1. let's drop it in. Now what's happening to the balloon? If you look closely, it may notice that it does appear to be, well, shrinking a little bit. Let's go ahead and continue placing this balloon into the nitrogen and see if it continues that. Now also use your ears. You may be able to observe, can you hear what's also happening to our balloon? And now for the great reveal, all right? 3, 2, 1. And you may notice that our balloon right now is completely and totally flat. Why does it go flat when it gets into the liquid nitrogen? Well, again, the nitrogen is extremely cold, right? And one of the neat things about air is that when air gets very cold, it tends to go ahead and compress and contract together. So warm air will go ahead and expand to fill its container, but cold air, just like if we were cold and we wanted to huddle together like we were children on the playground in the winter, we would go ahead, air goes and compresses together. And this goes and flattens our balloon. Now the air inside the balloon isn't gone, it's just cold and flat. Here's the fun part. I'm going to take this balloon now, and I'm going to go ahead and I'm going to warm it up by blowing on it. And let's go see what happens to our air when I do that. Are you ready? 3, 2, 1. And what's happened to our balloon? It's gone ahead and it's actually expanded back to its original size. Right? Again, cold air shrinks and sinks, warm air expands and gets larger, takes up more space. Now the fun part with this is, of course, we can do this with the balloon over and over again. So while I have a nice fun little hopping balloon that I can bounce around, the moment I put it back into the liquid nitrogen, and I let it sit too long in the nitrogen, it's going to get cold again and once again shrink down back to its original, well, flattened size. Now my next question for you guys, is balloons the only thing that can actually do this? Is air the only thing that shrinks when it gets cold? Let's go ahead and find out with our next experiments. Right? And for that, I'm going to need a simple ball and a simple ring. Now, does this remind you of any single game that you have ever actually played? If you said basketball, or Quidditch for you Harry Potter fans, you'd be right. And of course, the goal of basketball is rather simple. Go ahead and put the ball through the hoop. And as we see, this ball fits quite nicely and easily through the hoop. Right? What we're going to do now is we're going to take our ring, we're going to put it right inside of the liquid nitrogen that we just had sitting out. And I may need a little more nitrogen for this, so I'm going to go ahead and pour it on in. Get our ring nice and cold. Now, if our ring has shrunk just like our balloon did, do you think that this ball is going to fit through the ring? Well, let's find out. Let's go ahead and take our ring out. In 3, 2, 1. You'll notice it's stuck. I actually can't get it through until it goes ahead and heats and warms up again. If we want to go ahead and make it even colder, the warmer it gets when it sits outside the air, the larger the ring is going to become, so that will allow the ball to fit back through the ring. But the more that we go ahead and leave this right inside of our liquid nitrogen, the colder it's going to get. And the colder it gets, the more the ring shrinks, and this time it's well and truly stuck. I have one last fun experiment to do for you guys today. As you remember our very first experiment, what we did was we had a little bit of fun and heated the liquid nitrogen just in the air. Let's see what happens now when we go ahead and heat it with something even hotter, boiling water. So I'm going to take my liquid nitrogen that I have left over here, and I'm going to go ahead and pour it nicely into that bowl. And just because I have a little bit extra, I'm going to grab that and pour it into, so that we have a nice bit of liquid nitrogen here. Now all I'm going to go ahead and do next is take some hot boiling water and we're going to go put it in. Now what do you think is going to happen when we add this nice hot water straight into our liquid nitrogen. Go ahead and come up with your hypothesis. My camera person is going to go ahead and take a major couple steps back so that we can get to the full effect of this. Ladies and gentlemen, are you ready? Thank you very much. I hope you've enjoyed this live science. In 3, 2, 1.